The diagram below depicts the cross-sectional view of a long, straight current carrying conductor located between the poles of the permanent magnet. The magnetic field of a magnet and a current I are perpendicular. Calculate the magnitude and direction of the magnetic force on a 5 cm section of the conductor when the current is 2 amps into the page and B equals to 2 times 10 to the power of negative 3 Tesla. So in this question, we need to find out the magnitude and direction of the magnetic field. So first of all, I'm going to write down the equation for finding magnetic force, which is B times I times L times sine theta. B is the magnetic field strength in terms of Tesla, I is the electric current in terms of amp, L is the length in terms of meter, and sine theta, theta is the angle between magnetic field and the electric current direction. And that's going to give us the magnetic force in terms of Newton. So sine 90 is going to be 1, so we have just BIL. B is 2 times 10 to the power of negative 3. I is 2. And L is, it says 5 centimeter section. It is 5, you need to convert it to meters. 5 centimeter divided by 100 is going to be 0.05 meters. Now let's calculate it without using the calculator. 2 times 0.05, first of all, 2 times 5 is 10. So 2 times 0.05 is going to be 0.1. The whole thing here is going to be 0.1. 0.1 times 2 is going to be 0.2 times 10 to the power of negative 3. But 0.2 I need to change it to 2. So it's going to be 2 times 10 to the power of negative 4. That's how we do it. And the unit is Newton. Now let's find out the direction. The direction, we need to use the right hand rule, which thumb shows the direction of the current, which in this case it says it is into the page. So thumb is going to go into the page, forefinger is going to go toward the direction of the magnetic field, and then your palm, right hand palm, is going to show you the direction of the force, which in this case is going to go upward. So that's the direction of the magnetic force.